Hello, AP Environmental Science, and welcome back. We're going to talk about waste generation and waste disposal, just what you've always wanted to talk about, trash. Every school child in the United States has heard of the reduce, reuse, and recycle, the three R's. In recent years, composting has been added to this list and actions that we need to take towards adding other materials. So in this module, though, we're just going to examine the three R's and, of course, composting. So learn to describe the three R's and understand the process and the benefits of composting. So starting in the 1990s, people in the U.S. began to promote the idea of diverting material from the waste stream with the popular phrase, reduce, reuse, and recycle, also known as the three R's. This phrase incorporates a practical approach to the subject of solid waste management. And not that you need a vocabulary lesson, but we're going to look at each of these individually. Okay, reduce. It's the first choice among the three R's because reducing the inputs is the optimal way to achieve reduction, right? Especially when it comes to solid waste. So this strategy is also known as waste minimization or waste prevention. If the input of the material to a system is reduced, then the outputs will also be reduced. So in terms of waste, which means that there's less material used, and so there's less material to discard. We also call that source reduction. And that seeks to cut waste by reducing the use of several potential waste materials in early stages of designing and manufacturing. And even in many cases, the source reduction can also increase energy efficiency because it means that the manufacturing process less waste, and then it can begin to minimize the disposal process. So since fewer resources are being expanded upon, source reduction can be a huge economic benefit too. Source reduction in manufacturing can happen in several ways, all right? If the company creates a new packaging that provides the same amount of protection to that product but with less material, then that's a success story in source reduction. Source reduction can also be achieved by material substitution. So in an office where there's workers who drink a lot of water and coffee from paper cups, by providing every worker a reusable mug, that can reduce the municipal waste. So in some categories, we need to consider reusing rather than actual reduction. So let's reuse. The reuse of a product or a material is better than discarding it, I guess, right? Rather than disposing it, reusing it. It allows the material to cycle through the system longer, and so therefore it becomes an output. It takes a lot longer for it to become an output. So it means that the time that it's in the system is longer. That's what I'm trying to say. So ultimately, no additional energy or resources are needed for this object to be reused. So let's talk about mailing an envelope. That can be reused by converting the first address with the label and then writing a new address over on top of it. And here we are increasing the time for the envelope to be in the system before we throw it away. So energy may also be required to prepare or transport the object that needs to be reused. So certain companies reuse beverage containers by shipping them from the bottling factory where they were washed, sterilized, and refilled. And so although energy is involved in the transportation and the preparation of the container, it's still less energy than would have been needed to recycle or dispose of the actual container. So we've said before that the U.S. is a throwaway society, right? It is still practiced in many ways that we may not think about in order to reuse. People often reuse newspapers for animal bedding or even art projects, and many businesses and universities have a surplus of agents who, we need to find homes for. So we've seen like the reuse of products and things like flea markets or swap meets, and even popular websites like Craigslist or eBay, FreeCycle, and there's other ways that people reuse their own stuff. So reuse sometimes involves an expenditure and a little energy and can generate a little waste. In the transportation world, washing and sterilizing those beverage bottles, that's an example that energy is needed, but less waste is ultimately generated. All right, recycle, the third R. This is the process by which the material is designed to become something else. The municipality, that is it's where it's collected, and it's collected by its raw material, and then we use that raw material to produce a new object. So we divide our recycling into two different categories. There's a closed loop and an open loop type of system. So a closed loop recycling system is the recycling system that a product is recycled again into the exact same product. And aluminum cans, you can be familiar with this example, right? They're brought to an aluminum plant, they're melted down and made into a new aluminum can. So this process is called a closed loop because in theory it is possible to keep making aluminum cans from aluminum cans almost indefinitely. In an open loop system, one product, like a plastic soda bottle, is recycled into another product, like a fleece jacket. So although recycling plastic bottles into other materials is sending less plastic into the landfill, I want to point out that it does not reduce the demand of the actual raw material, which in a sense, when we're talking about plastic, we're talking about petroleum. So to make plastic into new bottles, you need more petroleum. Recycling is not a new thing in the United States, but over the past 25 years, it's been embraced a little more enthusiastically than it has in the past. Americans really haven't always embraced this idea of recycling, but I mean, if you look at the diagram here, you can see that we can use things like benzene, which is a horrible carcinogen, and other petroleum raw materials. They make carpet fibers, and of course, that's what we use to make part of our homes. If you look at the closed loop system, we're still in a closed loop of recycling, but again, we still have some petrol or oil products that we're still using to remanufacture and recycle those systems. And so there is a waste part of the process. This graph shows both the increase in the weight of the municipal waste in the United States from 1960 to 2011, and also the increase in the percentage of waste that was recycled over the same period of time. Interesting, right? So recycling rates have increased in the U.S. since about 1975, and today we recycle roughly about a third of all of our waste. In Japan, recycling rates are more than 50%, and some colleges and universities in the U.S. report that recycling rates are at like 60% on their campus. So extracting resources from Earth requires a lot of energy and time, and usually is considerable financial investment. So as we have seen, these processes of generating this waste and the pollution can occur on many levels. And so it makes sense for manufacturers to utilize the resources that we have already extracted, right? I mean, today in many communities, they're adopting this zero sort recycling program. It's a program that allows residents to mix up all types of recyclables in their container, and they deposit it into a curbside thing on the outside. And so basically it's transferred to a sanitation type of system. This saves time for the residents who were once required to sort their own materials. Wow, just making us lazier than we already were. At the sorting facility, workers, I'm hoping this is American workers, basically sort the materials that need to be sorted in their own little category, and that way they get the greatest output for their effort, because if a worker's trained, then they know where to properly put the item. The market for glass and paper is really kind of is weird and a little bit different than this whole plastic to make fleece and paper